All right, this is Chapter 7 Physics Practice Quiz. I'm just going to work through the problems and then I'll send out the real quiz, and it should be real easy because the problems will be very similar. Okay, the first one is just find the momentum of something. Momentum again is the given letter P because M is too confusing. It stands for too many other things and P wasn't being used. So P is equal to mv. As long as units are in kilograms and meters per second, we don't need to worry about anything. So times 30 meters per second. And actually, even if they weren't, you just write down the units. So 30 times 1200, let's see, 3 times 1200 is 3600, so I think that's 36,000 kilogram meters per second. So you just write down the units, momentum doesn't have a name, and we're good. All right, number 2. This is the impulse problem, which means that force times the time the force is exerted, sometimes they put a delta in there to say the time it's exerted, is equal to the mass of the object times its change in velocity. Most of the time the velocity starts from 0, so change in velocity is the velocity. So it could be written Ft equals mv. As long as you know what you're talking about, either way works. So in these problems, you're given 3 of the things, you find the 4th. In this case, we're given the mass is 1 kilogram, the hammer is a mass of 1 kilogram. It's moving, so the velocity is 15 meters per second, and the time is 0.11 seconds. So what is the force? So the force then is just mv divided by t. You plug in all the numbers. 1 times 15 divided by 0.11. As long as the units are kilograms, meters, and seconds, which they all are, we don't need to worry about it, and we know we'll get newtons, the thing we're supposed to get force in. So 15 divided by 0.11, and I get 136.36, so 136.36 newtons. So again, whichever one you don't know, you solve for, plug in the numbers, and it's pretty easy. And the idea of the formula is, again, if you exert a force for a period of time, you make a move. You change something with its mass's velocity. The longer you exert the time, the more you change the velocity, the bigger the force, the more you change the velocity. I mean, it makes sense, and that's just what that formula means. F delta t is called the impulse. For exerting a force for time is impulse, and mv is momentum. So exerting an impulse changes the momentum. Okay, number 3. This is the collision problem. This is an inelastic collision because they stick together. Elastic collisions, they bounce off each other. This is inelastic because they stick together. So I always like to draw a picture. So we have a 50 kilogram spaceship. Oh, that means I gotta draw a spaceship. Okay, here's my spaceship. It'll look like a bomb or something. So there's our spaceship. And it's going this way. It is 50 kilograms. That's not a very big spaceship. It's going east. Let's see, east is this way. Yes, it's because north, south, west, east. It's going that way at 10 meters per second. It crashes into a 20 kilogram spaceship, so it's going to be a smaller one. So there's our 20 kilogram spaceship. 20 kilograms going west at 30 meters per second. So which one wins? So that's before. And afterwards, they're going to be stuck together. So this is before they hit, and then they crash. So after they hit, we have one smushed together spaceship that weighs 70 kilograms. So mass is 70 kilograms. And we want to know what its velocity is doing. Is it going to go this way? Is it going to go that way? Okay, so what's the momentum of this one? This one's momentum, mv, is 10 times 500 times 50, which is 500. This one, its momentum is 20 times 30, which is 600. So this guy, even though it's smaller, wins because it's going faster. So we know that overall, it's going to be going this way when it's done because this one's momentum is going to win. And overall, the total momentum in the beginning is 100 momentum units in that direction. 600 minus 500 is 100. So this thing must have 100 in that direction too. 100 momentum units, or 100 kilogram meters per seconds. So 100, because the momentum before, which overall is 100, 600 minus 500, is momentum afterwards, which is 100 kilogram meters per second. So afterwards we have mv, our velocity after, our new velocity, mv is equal to 100 kilogram meters per second. We know the mass is 70, so the velocity is 100 divided by 70, which is 100 divided by 70, which is 1.43, about 1.43 meters per second. So when they stick together, we have a 70 kilograms smushed together spaceship moving at 1.43 meters per second. All right, hopefully that makes sense. It always helps to draw the pictures and think about before and after. So overall momentum before, which one wins, which one is the most, and how much it wins by is what it has at the end. That's the total momentum is 100, total momentum in the M is 100, momentum doesn't change, and so it must be going 1.43 meters per second. Okay, last one is just a explaining question. I'm just going to go through this in words and pictures. I'll let you put the words down on paper. So it says, why letting a ball bounce off your chest back the way it came is more likely to knock you backwards than catching it. So if you're on the edge of a cliff and someone throws a ball at you and you can't duck or anything, do you catch it or let it bounce off? And if you don't want to fall off the cliff, you should catch it, because if it bounces off you and bounces back the way it came, it is more likely to knock you off. And the idea is here, you have a ball and its momentum is going this way, mv. At the end, the ball is now going this way at mv. So what's its change in momentum? So the momentum change by 2 mvs. It started off going left, it ended up going right. So its change in momentum, which is the momentum before minus the momentum afterwards, and minus a negative is plus a positive, is twice the momentum. And where does it impart that momentum to? It imparts it to you. So you get 2 mvs, because not only does it hit you, it's like you're throwing it back. So it hits you, you throw it backwards, and it changes its momentum twice, which means your momentum also changed by that much, and you're going to go the other direction when it hits you. Now if you catch it, you just take its momentum, and its change in momentum is only mv. You take its momentum, it stops, you absorb mv of momentum. Hopefully you can transfer that to the earth by having friction on the ground and transfer it all to the earth, and then you're good, you don't get knocked over. But if it bounces off you, you have twice as much momentum to transfer, and you might not be able to, and it might knock you backwards and you'd fall over. Okay, so that's the idea. When it bounces, you have twice the momentum transfer, versus you catch it, then you just absorb its momentum once, not twice. It doesn't when it bounces back. So you're more likely, if you want to knock something over and you have certain mass of a ball, it's better to use a bouncy ball. A bouncy ball will knock it over twice as easily than something like a clay ball that just sticks to it. So, okay, hope that makes sense. And that's it for now.